All right, well, this is our first kind of quick review set of notes. A lot of this is stuff you should have learned last year, or even in algebra, but just kind of just some reminders, just to kind of get us started here this year. And to be honest, this first page was meant to be kind of for you to explore on your own in class, and then we would work through the notes, the back ones there together. But I'll go ahead and just fill these in with us real quick. Or if you don't want to listen to me drone on, you can just Google it. Right. So what's a function? What's a relation? Right. So I'm actually going to start before I answer what a function is. What is a relation? So in mathematics, a relation is just any pairing of inputs and outputs. That's it. Right, so I put something in, I get something out. That's all a relation is. Okay, and so a function is just a special relation, right? A relation in which each input gives exactly one output. Right, so a relation then is just any time you pair an input and an output, and a function is just a special type of relation in which each input is going to give you exactly one output. Right? So it says, can you give 3 examples of a function? So I asked you to give one graphically, right? So this would be a function, right? Because for each input, an x value, I get one y value out. And then actually just to compare that right below what's a non-function. So if it's not a function, then like we could do a sideways parabola, right? Because what that is showing is, right, for each input, I'm going to get 2 outputs that correspond to that, right? So basically, right, one input gives me that one output versus down here an input gives me 2 things that correspond to it. Right? So that's a function versus not a function. Excuse me. Example of an equation. So if we just actually did the same thing, y equals x squared, right? That would just be a parabola. And so same thing for each x that I plug in. There's only one y that I get out. But if I were to flip that around and make it y squared equals x, now that's not going to be a function because for each input that I put in, I could get out 2 outputs. Right? So for example, if I were to plug in, if x was 4, then y could be both 2 and -2. So, and then finally it says, can you also give one where it's a set of ordered pairs? So for example, if I were to say just a list of ordered pairs, like 1 gives me 2, 3 gives me 5, and how about 7 gives me 10, right? That's a function. It's a very simple function. It's just 3 points saying that, right, when I plug in 1, I get out 2. When I plug in 3, I get out 5. When I plug in 7, I get out 10. And then if I were to come in here and say, okay, well, what if instead I change this to say 1, 2, and then maybe, heck, I'll just keep this 3, 5. But then what if this one had been 110? Right, so now the value of 1, the input of 1 gives me 2, but it also gives me 10, right? So that's not a function. Right? Well, the majority of mathematics is, at least in the beginnings of high school, is spent dealing with functions. But we also like to talk about, well, what's not a function, right? And so if I were to say, what's the domain? Then the domain, right, is the set of all input values. That's all the domain is. So it's everything you're allowed to plug in. Okay? So if I look up here to number 1, this graph is telling me, so it says, can you state the domain of your 3 examples, right? So if this function, those arrowheads tell me it goes on forever, so that's basically saying I could plug any x value in, and there's going to be a y value that corresponds to it, right? So then we could say that the domain is all real numbers. That's the fancy symbol for it. Or you could say, you could just write it out, all real numbers. Or if you used interval notation, you could say everything from negative to infinity works. Those are all acceptable. Number 2 up there, same thing, y equals x squared. So what can we plug into that? All real numbers. Or we could say from negative infinity to infinity. And then number 3, what's the domain? Well, this one's a little bit different, right? It's just 3 points. So the domain is quite literally just the 3 x values that you're allowed to put in. So that's a 1, and then 3, and 7. That's it. So we would just list them out, right? And so again, the set of all input values, so I'm going to put this real quick here. It's usually x, right? Because usually a function is written in terms of x and y. But it could be other letters, right? It could be t for time or different things. But it's basically just all the inputs. And then, of course, that means that the range is the set of all output values. So if we come up here and look at our picture, so this parabola that I happen to draw here looks like, right, the highest, or the lowest, I should say, y value, maybe we'll say that's at 1. So we could say that the range of this is y is greater than or equal to 1, maybe, right? Like all the y values from 1 and up. Or in interval notation, we could say from 1 to infinity. That would work. For the number 2 that we picked up there, y equals x squared, that's just a parabola, and whose origin is at the vertex is at the origin. So for that one, we could say it's going to spit out everything greater than or equal to 0. So we could say from 0 to infinity. Right? So because it would look like this. Right? So the starting at a y value of 0 and going up forever. And then again, when it's 3 points, you literally just list it. So you're saying, okay, well, the only y values this could possibly be are 2, 5, and 10. Done. And so for the range of that one, it's just the 3 y values that came out. So, okay. All right. All right, so the whole thing then, a lot of times what we like to talk about is what is the domain of a function. In other words, what are we allowed to plug in? Okay, so if I was there in class, and so I'll bring it on Thursday, I've got a toaster, and I always like to use the example of what do you put into toast, or what do you put into a toaster? You put in bread, and you get out toast, right? So the input is bread, and the output is toast. And so if a function is just that, if a function is just putting in inputs and getting out outputs, another way to think about it is what are you allowed to put into your toaster, right? So like if this is the function right here, right, what am I allowed to put in there? What x values will work? And so to be honest, the assumption is pretty much everything. And then we just look to see if there's any problems. So if I look here at this first one, I'm going to say, well, you know what? I'm going to say the domain is everything from negative infinity to infinity. And then the question is there any problems? Like, is there any number out there that I can't square and subtract 7 times that number? No, right? I mean, I can do that to any number and it's going to work. So the domain is truly everything, okay? And so then I look at the next example and say, okay, well, what about this? Can I plug anything into this function? So like, can I plug in a number, multiply it by 3 and add 2? Yeah, pretty much anything you can do that to. And what about the bottom here? Can I square a number, subtract 2 times that number, and then subtract 3? Yeah, that seems okay. However, in mathematics, at least up until now, there's really only a few type of functions that have limitations. And one of those is fractions, right? Because down here in the bottom, we're not allowed, right? Cannot divide by 0. So one of the type of functions that we have to always be careful of is fractions. Functions that have a denominator. Because we're trying to figure out, well, what would make that denominator 0? So if I were to take x squared minus 2x minus 3 and set that equal to 0, I've got lots of ways to solve that. But the fastest way would just be factor it. And so it multiplies to -3 and adds up to -2. So if I set each of those factors equal to 0, I'm going to find out that at -3 and 3, -1 and 3, right, that's going to create a 0 there in the denominator. And I'm not allowed to divide by 0, right? So basically what this is saying is, hey, if you were to take a value of 3 and plug it into this function, like up top, I'm going to get 11, right? That's not a problem. 3 times 3 plus 2. But in the bottom, I'm going to get 9 minus 6 minus 3, which is 0. So I'd get 11 divided by 0, and I'm not allowed to divide by 0. So therefore, 3 is not something I'm allowed to put in the toaster, right? It'd be like shoving a fork into the toaster. So that is not a valid input. So for the domain here, we could say that you can do anything, right? All real numbers, let's say. That's the fancy symbol for real numbers. It's like an R with a double line. But x cannot be -1 and x cannot be 3. Basically saying, look, everything is valid except -1 and 3. Can't use those. Right? And then another type of function that we have dealt with in your math career so far that tends to have domain restrictions is square roots. Because if you recall, right, you cannot take the square root of a negative. Unless you want imaginary numbers, right? So whenever there's a square root, then we know that, oh, that could lead to some issues. So for example, on this one, then we could say, well, I know then that 3x plus 12, since that's underneath the square root, I know that that has to be greater than or equal to 0, right? I can't take the square root of a negative number. So if we solve that, we get 3x is greater than or equal to -12. So x is greater than or equal to -4. And so that actually is our domain then, right? We're saying, hey, you're allowed to plug into this function anything greater than or equal to -4. So that would be the domain then. If I wanted that in interval notation, I could do -4 to infinity. Or you could just leave it x is greater than or equal to -4. Okay. So it's telling you, look, you're allowed to plug in anything as long as it's a value bigger than or equal to -4. If you go less than -4, it's not going to work. So for example, if I plugged in -5, right, this would be -15 plus 12 is -3. I can't take the square root of -3. So that wouldn't have worked. Okay. And so then this last one here is basically just combining the two things, right? So it's saying, hey, here's the two issues that we know of right now that tend to be problems. We can't have square roots and we can't have fractions. Those are the two things that lead to problems. So as before, I can say, well, hey, 14 minus 2x, that's under the square root. So I know that has to be greater than or equal to 0, right? I can only take the square root of things that are greater than or equal to 0. Ooh, but this time it's in the denominator of a fraction. So that means, boop, I actually just want to know when it's greater than 0 because it can't equal 0 either, right? Because if I were to equal it to 0, then I'd be dividing by 0, and that's bad. Right? So if I solve this, I can add the 2x over, divide by 2. So I get when x is less than 7. There's my domain. So what I'm allowed to plug into this toaster is anything from -infinity up to 7. Put a parenthesis around the 7 because that means I don't want to include it. Because if I actually plug 7 in, right, and just to double check it here, right, Look what happens if I plug 7 in. This would have been 14. 14 minus 14 is 0. Square root of 0 is 0, but I can't divide by 0. So I can't actually include the 7, right? So I can basically plug in anything up to 7, but not 7 itself. So there's just kind of practice with domain issues as far as algebraically. Okay, so you can give those a try. There's a couple of those in your homework. And then finally, just a little bit more with function notation. Okay, so this says, given this lovely function, okay, what's f of 2? So remember the way that we read this is we say f of 2. Right? And all that means is that the input is 2. Right? This is just telling the reader that the input is 2. Right? So I'm going to do 2 squared plus 3 times 2 plus 5. So that would be 4 plus 6 plus 5. Except I just wrote 15 because I was a step ahead. My answer is 15. Right? So f of -1 just means that the input is -1. Okay, so that's just telling us what are we going to put into the function. We're going to input -1. The main thing on this one is it's -1 squared plus 3 times -1 plus 5. Right? So you just got to be careful there because you're squaring a negative. So this would become 1 minus 3 plus 5. So what -2 plus 5 is 3. Okay. So then what the heck does this next one mean? F of x plus 3. Okay. It's the same idea. This is just the input. So it's just saying that you're going to input the quantity x plus 3. So just like over here, when I inputted -1, it just said everywhere there's an x, I'm going to replace it with -1. That's all this notation means, right? So this is just saying you're going to replace x with x plus 3. So everywhere there was an x in the function, it got replaced with x plus 3. So that's really all it's saying to do. Now we can simplify that a little bit, right? We can square this. So we'd have x squared plus 6x plus 9 plus 3x plus 9 plus 5, right? Don't forget that when you're squaring x plus 3, right? X plus 3, that's what that means, right? So foiling that out, multiplying that out, x squared plus 3x plus 3x plus 9, right? That's where I got this, okay? Common mistake. And then we could just combine like terms. So what do we get? X squared, 6x and 3x is 9x's. And then what, 18 plus 5, so plus 23. So that's what the function is when I replace it, x with x plus 3. That's all that means. Okay, and so a lot of this is just notational stuff. It's just making sure you understand the manipulation of these things, right? So f of x plus h, this just means I'm going to replace x with x plus h, right? So this is just saying, just like before, but instead of a 3, right, x plus 3, now I'm just going to leave it as another variable, x plus h squared plus 3 x plus h plus 5. So that's all that's saying. Oops. If I wanted to simplify that, I could. So this would be x squared plus 2xh's plus h squared plus 3x plus 3h plus 5. Not much that combines there, right? That's as good as it gets. So kind of ugly and gross, but that's it. So then when you look at this next one, E, you may get a little freaked out and say, what in the world is going on? Like, this is this big giant mess. But really, it's just saying take this one step at a time, right? So this is saying, hey, what is f of x plus h? Oh, well, we actually just found that right there, right? That's f of x plus h. So I get x squared plus 2xh plus h squared plus 3x plus 3h plus 5, right? That's all that means. Then it's telling us, well, now you want to subtract f of x. Okay, so I'm going to subtract f of x. Well, what was f of x? It was this original function, x squared plus 3x plus 5. And then I'm going to divide that whole thing by h. That's all that means. Now, I know that looks really gross, but a lot of stuff's going to simplify for us. So it's just saying take f of x plus h, find what that is, now subtract the function f of x, and now divide it by h. So when I do that, let's see, we'll simplify. So we get x squared plus 2xh plus h squared plus 3x plus 3h plus 5. When I distribute that negative, I get negative x squared minus 3x minus 5 all over h. And then a lot of stuff's going to cancel out for me here, right? So those x squareds cancel, my 3x's cancel, my 5's cancel. And so if I look then, I actually up here at the top, I can factor out an h. So if I were to take an h out of what's left, so actually let me rewrite it here. So 2xh plus h squared plus 3h all over h. So if I factor out an h, I'd be left with 2x plus h plus 3 all over h, right? Whoop, whoop. Those cancel out. And so I'm actually, my final answer is just 2x plus h plus 3. There you go. So there's a couple of those for you to try on the homework. And actually tonight, just do 1 and 2, problems 1 and 2. They each have several parts, but just do that. And then we will continue with this stuff tomorrow. We'll finish out these notes tomorrow. All right, that's it for now.